Congratulations, my friends. We end the exciting termination of our lectures in Module 1. With this little discussion, we will examine some problems and how to solve for z-scores. And the next, we will look at terms and definitions that you need to know. It's been exciting. I appreciate your patronage. We will start out with this problem. As always in any problem, the first thing you do is read the problem, then you identify what type problem it is, and then look for a means or a formula which might help you solve it. We read this and we see if it says find the z-score for a raw datum of 58 when mu equals 94 and sigma equals 32. Obviously, this is a z-score problem. We would know that because we're in the section finding z-scores, obviously, but we would see that in the problem. This is also a population since we have mu and sigma. This would be our formula, and then we would plug into the formulas the values that we know from the problem. We know that x is 58, sigma is 94, and we know that our mu is 94, and sigma is 32. We would plug that in, then we would solve the numerator first. 58 minus 94 is negative 36. Now we would divide, and lo and behold, we have a z-score equals negative 1.125. Now, it's important at this point that you understand not just that you have found a z-score, but what that z-score says about the raw datum. The z-score is the number of standard deviations above or below the mean that the raw datum lies. We notice that the z-score is negative, so we know that the datum is below the mean. And lo and behold, if we identify negative 1.125, we find that the datum lies approximately here on the curve. Z-scores are very powerful because they tell us where on the curve the datum lies. Now, let's look at another one. Find the z-score for a raw datum of 208 when x bar equals 175 and s equals 59. It's interesting to us that when we do this, we know that this is a sample because we have x bar and we have s. We would use this formula. We would plug in, we would simplify, and we find that our z-score is equal to 0.56. Again, we would interpret the z-score. The z-score is above the mean, and it's 0.056 standard deviations above the mean, which would let it be located right here. We have one other unique problem that we're going to do. In this problem, we're not looking for a z-score, we're looking for a raw datum. And it says find the raw datum value for a z-score equal to 2.05 when mu equals 145 and sigma equals 40. Obviously, this is a population since we have mu and sigma. We would use this formula. We would plug in the values that we know. Now, we know that our z-score is way out here, 2.05 above the mean. We find that mu is 145. We would plug that in. The z-score is 205 and sigma is 40. Now all we have to do is algebraically solve this problem. We would multiply both sides by 40. And we come up with 82 equals x minus 145. Add 145 to both sides, and we find that our raw datum is equal to 2.27. Very interesting. Just a little simple algebra. That's all it is. I love that phrase. So rested he by the algebra tree and stood a while in thought. Again, I want to thank you very much for your support. I appreciate your patronage. Had a big holiday. Looking forward to more. You have a very good day.